Now on to the solution for the problem. From the data taking higher losses on the sides of owned machinery into account. The monetary disadvantages can be calculated as follows. 0.5% of 70 decitons yield per hectare multiplied by the market price of 18 euros per deciton results in a financial disadvantage of 6.30 euros per hectare. This amount is now to be added in the formula for calculating the minimum extent of utilization on the side of the owned harvester to the variable costs for owned machinery. The result is the minimum extent of utilization for the owned harvester of 592.5 hectares per year. Now this is about 50 hectares more than the originally calculated minimum workload of 543 hectares. The disadvantage resulting from owned equipment favors the use of the service provider. Due to the technological advantage of the service provider, it makes economic sense only to invest into own equipment when a higher workload can be reached. Of course, both effects, the timeliness costs of the service provider and the yield losses due to technological disadvantages of owned equipment, can be studied simultaneously. Therefore, we have on the one hand, as established, the disadvantage of owned equipment of 6.30 euros per hectare, and on the other hand, the timeliness cost of 22.40 euros per hectare for the service provider. If we insert both values into the formula for the MEU at the points already shown, meaning to add the disadvantage of owned machinery to the variable costs and the timeliness costs of the contractor to his billing rates, we obtain a new MEU of 447.6 hectares per year. We summarize. The costs of owned equipment when used as a workload of 600 hectares per year, including the fixed machinery costs, variable machinery costs, and wage claim, amount to a total of 117.83 euros per hectare. In comparison, the rates for external mechanization through a service provider are 125 euros per hectare. Internal mechanization, that is owning equipment, is thus cheaper than external mechanization through a service provider. This applies even if the annual workload of the combine harvester is lower, as long as the rising costs of internal mechanization due to the lower workload remain equal to the billing rates of the contractor. The costs are balanced at an annual workload of 543 hectares, assuming equal quality of work. Timeliness costs on the side of the service provider work in favor of owned equipment, so this solution is already economically viable at an annual workload of only 418.8 hectares. Technological disadvantages on the part of owned equipment and associated higher yield losses compared to the more modern machines of the service provider improve the favorability of the service provider, so that internal mechanization would only be economically viable at an expected workload of 592.5 hectares per year. Considering both effects simultaneously, it can be seen that in the supposed case, the timeliness costs of the contractor are outweighing the technological disadvantages of owned equipment, because compared to the original version with 543 hectares per year, the minimum extent of utilization is only 447.6 hectares per year, which is almost 100 hectares less than at the same quality of work. Certainly, there are further examples to find which favor either internal or external mechanization. As shown in these two examples, the calculatory procedure remains the same. We have now reached the end for the calculation example of the combine harvester.